From censored files to clear evidence, this is Redacted Realms.
Is it possible that humanity originated from space? Today, extraterrestrials are a scientific topic, widely studied in many countries around the world, with numerous differing views on their appearance in human history. Most believe they came from Earth and helped us build ancient civilizations. However, some other opinions suggest that extraterrestrials arrived here billions of years ago. They came to Earth in small forms, without tall, slender bodies, pale skin, or traveling in modern spacecraft. When they awakened in a suitable world, they evolved and developed until today. If you want to know what they look like, you just need to look in the mirror. That is the beginning of the issue of life's origin on Earth. It's very likely that everything around us is made from life seeds, not originating from this planet. It seems fantastical, yet has a solid foundation. So how did those life seeds get here? Why can they exist and form in the universe? Let's explore with EGT right now. Over 4 billion years ago, Earth was very different from today. The planet was submerged in water, a vast ocean covering everywhere. The ocean at that time was no deeper than 30 meters. Countless volcanoes erupted in various areas, spewing molten material flows, creating some small islands. The atmosphere then was a cloud of dust, many toxic gases, and completely unsuitable for living organisms. At this moment, a spacecraft from outer space approached Earth. It carried extremely special cargo. They were cocoon-shaped capsules, the size of a small four-wheel car. Inside each capsule contained billions of life seeds capable of reproduction and development. They had no nucleus but carried an extremely important treasure for life. The spacecraft door opened. The capsule containing life seeds was launched toward Earth. Immediately after completing the mission, the ship with the remaining life seeds departed to other suitable planets. The life seed capsule plunged into the atmosphere. It was designed to withstand physical impacts. It collided with the ocean surface, creating a violent explosion, dispersing life everywhere. Most single-celled organisms would die in the water immediately, because the temperature was very high. Surviving organisms would thrive around underwater volcanic vents. Organisms adapted, evolving more diversely. Small islands from rock turned into lush oases. Those who sowed the life seeds knew it would take several billion more years for intelligent life to develop from the DNA of the first single-celled organisms. What if we replaced the alien source of life with a meteor or comet from outer space? Even with changes, life would still occur similarly. More and more scientists believe life on Earth was not born on this planet. That originated from outer space. That theory is called panspermia. According to this hypothesis, life on Earth originated from other regions in the universe and arrived here via comets or meteorites colliding with Earth's surface. So far, there has been no concrete evidence to prove this concept. But important discoveries in the last century have made this hypothesis more plausible. So what have we discovered? The proponent of this hypothesis was Svante Arrhenius, the famous Swedish chemist who won the Nobel Prize in Chemistry in 1903. Before the panspermia theory emerged, the accepted theory about the origin of life was the biological process, where inorganic matter formed organic matter in the primitive environment. It occurred about 3.5 billion years ago. At that time, simple organic molecules appeared through interactions between matter and various forms of energy sources. They accumulated increasingly, forming the primitive premise for life. And through reaction processes, actual life was formed. However, according to this hypothesis, life must originate and form from outer space. Is this feasible or not? Life in outer space is very difficult to sustain even in its most basic form. To test the endurance of life under extreme conditions, Arrhenius exposed microorganisms to super cold temperatures in the laboratory, near absolute zero. If these organisms truly came from the universe, they must be able to adapt to such temperatures. Absolute zero may not sound too extreme, but we're talking about temperatures colder than the coldest places in the universe. The results showed that no organism survived. Arrhenius was very disappointed with this result. However, a glimmer of hope appeared when he gradually increased the temperature to lower levels. And most organisms showed no reaction. But some were activated. A miracle happened, they were still alive. The ability to survive in such unimaginable cold. Certainly not a result of natural selection. Earth has never had such a cold environment. This is an ability developed in another world. Organisms capable of surviving in such extremely harsh conditions are called extremophiles. When humans learned about the existence of such organisms and began searching, they realized that life appears everywhere. Through experiments, we see that life can exist in extremely low temperature conditions. But what about extremely high temperatures? In 1977, scientists discovered many hydrothermal vents on the ocean floor. Hydrothermal vents are fissures on the planet's surface that produce a body of water heated by geothermal energy. Hydrothermal vents are commonly found near volcanic areas, where tectonic plates are moving apart. Ocean basins or hotspots. Hydrothermal vents are very common on Earth, because Earth has both strong geological activity and a large amount of water on the surface and in the crust. Common terrestrial forms include hot springs, hot lakes, and steam vents. Perhaps the most famous terrestrial hydrothermal vents are in Yellowstone National Park in the United States. Submarine hydrothermal vents are called black smokers. The areas around them are highly biodiverse, boasting complex organisms nourished by chemicals dissolved in water. These chemosynthetic bacteria form the foundation of the food chain, supporting various organisms such as giant tube worms, mollusks, shrimp, and marine crustaceans. Although temperatures at hydrothermal vents exceed 400 degrees, life forms can still survive and thrive remarkably. No one knows how their DNA remains undamaged at such temperatures. How can these organisms live under such tremendous pressure? Humans cannot survive at great depths without protection. We can only withstand pressure equivalent to 5 to 6 atmospheres. While discovered organisms exist at pressures of 300 atmospheres. Atmosphere or ATM is a unit of pressure not part of the International Measurement System. This value represents the average atmospheric pressure, measured at mean sea level at the latitude of Paris, France. Surviving in extremely cold or hot environments. Organisms can also exist in acidic, oxygen-deprived, or any harsh conditions. Space is a more extreme environment than anywhere on Earth. You have no atmosphere to protect against cosmic radiation. Temperature fluctuations span hundreds of degrees Celsius. More dangerously, radiation and temperature in vacuum are innate. Space is a vacuum environment where air molecule pressure on the body is nearly zero. It will affect temperature, causing liquids to boil and turn into gas. In space, there is almost no atmospheric pressure, so the boiling point of liquids drops significantly. 70% of the human body is water, which would be a complex issue. Blood, sweat, tears, and body fluids would boil and evaporate instantly. The vacuum in space would also suck air out of your lungs in an instant. The continuous boiling of body fluids would also create a cooling effect. The evaporation of water molecules absorbs heat from the body, freezing parts near the nose and mouth. Humans cannot survive more than 2 minutes in space without protective gear. In contrast, some animals can do it. In 2007, over 3,000 tardigrades were sent into space by the European Space Agency for 12 days. Initially, they did not expect any individuals to survive in return. This rather ugly-looking creature is actually the world's most indestructible animal. They had existed on Earth for about 530 million years, predating the appearance of dinosaurs. They possess peculiar characteristics and are a fascinating research subject for scientists. This organism withstands temperatures from near absolute zero to above the boiling point of pressure 6 times than at the deepest ocean point, ionizing radiation hundreds of times stronger than the vacuum of space. They live without water or food for years when the body contains only 3% water or less. They are found worldwide, from the Himalayas above 6,000 meters to ocean depths over 4,000 meters. After 12 days in the space mission, 68% of the 3,000 tardigrades returned intact. Not only were they not destroyed, they also reproduced new generations. This proves that life can definitely exist outside the universe. It is entirely plausible that they multiply and survive in meteorites or some planets that fall to Earth for collisions. To transport life across the universe, life seeds must survive millions of years, which is very unlikely. In 2020, scientists found a sedimentary rock sample at the ocean floor. It lies at a depth of over 4,000 meters, dating back more than 100 million. They placed it under a microscope and were utterly amazed to see countless microorganisms in a state of hibernation. They hadn't completely lost their viability and turned into fossils, but were merely inactive. Researchers are trying to revive those organisms and have obtained unexpected results. The 100-million-year-old microorganisms not only woke up as expected but also multiplied immediately. After 68 days, they obtained up to 1 million cells per cc. This shows that life seeds can sleep for millions of years while traveling between planets. We already know that life on Earth began millions of years ago. The 100-million-year-old life seed is still insufficient to prove its origin from outer space. At the time over 3.5 billion years ago, life couldn't survive under extremely harsh conditions. Earth formed about 4.5 billion years ago, with the earliest period called the Hadean Eon. It refers to the phase when the planet was still in gaseous form, entirely dusty clouds not fully combined. Overall, the entire planet resembled Earth was so hot back then that rocks couldn't solidify to form a solid surface. Next was the second period, the Archean Eon, when the crust solidified and oceans appeared. The atmosphere was a mixture of methane, ammonia, and many other gases. Although not ideal conditions, it was sufficient for life to begin. The problem is how to prove it. Fortunately, Earth has many places preserving rock samples from geological periods like the Isua Greenstone Belt in Greenland. In 2016, researchers announced ancient traces of 3.7 billion-year-old living organisms found in southwest Greenland. At that time, the research team presented arguments based on morphology, chemistry, and the layered structure of the fossils. With sizes from 1 to 4 centimeters, each piece belongs to traces of stromatolite. In Greek, stromatolite is a layered sedimentary structure formed in shallow waters by microorganisms trapping sediment, particularly cyanobacteria. They can be found in freshwater, saltwater, and evaporated sediments in many places. If not convincing enough, go to Jack Hills, which formed from the early Hellish period. Although there are no signs of life, there is the presence of zircon crystals. This is an extremely durable material among materials formed on Earth. It grows in volcanic rocks, thinner than a hair but nearly indestructible and outlasting even the volcanic rocks that nurtured it. This is a mineral belonging to the silicate group, combined with molten magma and some non-concentrated elements. It incorporates stable elements to form its own structure. Its crystal structure is tetragonal with diverse colors from colorless, yellow, gold, red, brown, blue to green. Recently, scientists discovered a zircon crystal in Jack Hills, Western Australia. Analysis showed this crystal dates back 4.4 billion years, becoming the oldest solid specimen on Earth. Through research, they concluded it formed from the cooling of magma not long after Earth formed. What other evidence is there? Specimens dating over 4 billion years prove life developed under harsh conditions before oceans covered Earth. During the period when humans didn't have a protective atmosphere, meteorites easily attacked and collided with planets. According to the panspermia theory, meteorites are what brought life seeds to Earth. And the common hypothesis that meteorites are the origin of life has been excluded from scientific discussion. People consider this an unrealistic and baseless theory, but with the discovery of ancient life, everything has changed. Although meteorites could attack Earth, for many years we haven't found any life forms on them. They are masses of material consisting of dust, ice, and other elements wandering in the universe. How do we know if celestial bodies have conditions for forming life? Space science progresses quickly. We don't need much time to have probes land on meteorites and comets for inspection. The European Space Agency's Giotto probe launched to perform the first mission studying the comet. It flew 150 million kilometers into space to study Halley's Comet in 1986. Halley's Comet is named after the British astronomer Edmund Halley. It belongs to the short-orbit comet type, visible every 75 to 79 years. Although over centuries many long-orbit comets have appeared brighter and faster, it remains a special factor. The Giotto probe discovered Halley's Comet looks like a black, dusty beam. The comet's nucleus ejects gases and many material fragments through the solar radiation pressure. Among the materials it ejects is hydrogen cyanide, a precursor to amino acids necessary for forming life. And perhaps Halley's Comet is the vehicle transporting life seeds back and forth between planets in the universe. In 2004, humans for the first time not only flew past a comet but also landed on its surface. Launched in March 2004 on an Ariane rocket from the Kourou spaceport in French Guiana. The spacecraft caught up with, orbited, and sent a probe down to Comet 67P. The task sounds simple but required a very long journey. It required scientists to perform complex orbits with 4 gravity assist maneuvers. 3 from Earth and 1 from Mars to achieve the necessary speed to catch Comet 67P. During that time, the spacecraft also approached many asteroids along the way. After years of effort, the success brought humans extremely valuable information about Comet 67P. Through images, we see Comet 67P is actually emitting water vapor. Except scientists still haven't found why the water vapor is ejected in jet forms. Along with water, 67P's surface also has a mixture of ammonia and salts. This was already an unimaginable achievement, but everything is even more astonishing. After the comet samples were brought back to Earth, they not only confirmed the presence of ammonium salts but also glycine amino acids. Basic organic substances like building blocks of life exist on comets. Trillions of objects exist in and around our solar system today. There are even many more and more diverse than that. Through dispersion, they could bring water and organic materials to Earth. There's something we forgot to mention, that was billions of years ago. Large comets and asteroids only collided with Earth after many millions or tens of millions of years. But smaller meteorites collided with our planet more frequently. We only keep debating whether Earth formed 3 billion years ago or 4 billion years ago. But forgot about a strange thing that happened with life on Earth. About 500 to 600 million years ago, that event is called the Cambrian explosion. It describes the relatively rapid appearance, evidenced by animal fossils from that time to now. Around 580 million years ago, organisms mostly had very simple structures, mainly individual cells. After 70 to 80 million years, the evolutionary rate increased exponentially. Diversification began with life as we know it today. Accordingly, 570 million years ago, meteorites landing on our planet, much more complex biological material. They carry bacteria, amino acids. On March 13, 2018, in the journal Biophysics and Molecular Biology, the cause of the Cambrian explosion, which contained information about flagella. Octopuses might be alien creatures and came to Earth with a comet. About 570 million years ago, why are they suspected of not originating from Earth? How are they different from other organisms? After research and investigation, scientists discovered octopuses have as many as 9 brains, similar to humans. Octopuses have a central brain as the nerve center, but this brain only contains 10% of the neurons. Throughout the body, 30% of neurons are located in the optic nerve lobes. The remaining 60% are in the 8 tentacles, equivalent to human hands and feet. And its 8 tentacles all have intelligence. They're controlled by their own nervous system. Octopuses have up to 3 hearts distributed in different locations. Each heart has 6 different functions. The distribution of nerve cells also makes their memory incredible. It once used terrain and other organisms for camouflage. Amazingly, their tentacles contain up to 33.63 meters of protein. Why is that? To bring the DNA and life of octopuses to Earth, 2 conditions must be met. Develop on a planet relatively similar to Earth, and close enough to be able to follow meteorites to our planet. And the only one close to us could be Mars. A meteorite discovered in 1984 in the Allen Hills region of Antarctica. At that time, this meteorite was numbered ALH84001. But it hadn't received much attention. In 1994, Researchers through chemical and microstructural analysis discovered it originated from Mars, extremely special. ALHE 4001 contains complex chemical, abbreviated as polycyclic aromatic hydrocarbon. In addition, there are sulfides combined with magnetite. Because normally these two substances don't coexist in natural environments. Along with that are nanostructures, with shapes very similar to certain types of bacteria. The hypothesis that Mars seeded life onto our planet is very likely true. Could life have developed more strongly on Mars? Life began forming on Mars rather than Earth. Although water is necessary for life, but the appearance of water limits the production of the components that constitute life. History has long indicated that it seemed to be covered by an ocean in its early period, when life began in shallow waters, being more exposed to sunlight, and drying out periodically, leading to the stabilization of organic molecules, eventually forming complex organic layers, building the foundation of life. Life on Mars might have started more easily. And you? Where does our life source come from? Please leave your thoughts in the comments below. Don't forget to like, subscribe to me. For now, goodbye and see you again. Subscribe to Lala School channel.
If this file opened your eyes, subscribe and open the next case.